Okay, the last talk of this session is based on a paper written by Roberto Confogliani, Joe Cornelli, Alison Pease, Enric Plaza again, and Marco Schorlermer. And the talk is called Using Argumentation to Evaluate Concept Blends in Combinatorial Creativity. It's all yours.
Okay, I think I'm going to talk not only about argumentation, but about something similar to goals, but they are not goals. First, I have to say that this is a study paper, so it's an ongoing research. There are some things that are implemented, others that are under discussion, but we want to share some ideas here. One of them is that in addition to this optimality criterion or other measures of numeric nature that we may use to select or put priorities or rankings on possible blends, that, as was said by Amilcar, you can have possibly a big number of blends. We can also think about evaluation as a kind of open social context in which different actors or different groups have opinions about the quality or the pros and the cons of any particular blend. And the general idea is to use computational argumentation, which is a flourishing field in AI these days. In this particular paper, I will talk again a little bit about blends and amalgams very fast. We will have a specific domain that would constrain the possible representations that we may have, which is the representation of computer icons, here understood as a semiotic system. And then we'll show some examples of the kind of arguments that a system could have with external advisors, and some discussion at the end. So we don't have goals, but I have, if creativity is not ex nihilo, I mean, it can never come from nothing. You have to come from knowledge, from experience, from a lot of things that you have. In some sense, there has to be some sort of purpose when you're creating. Amilcar said that according to this cognitive science, we are building or trying to build blends all the time, but they are not without context. They should be in some context building some kind of blends. So this would be the overall picture in the long run that I would like to work with. So on the left, I'm calling this the rich background, which is all the knowledge, the experience, whatever it is that I may use in a specific field, like storytelling or computer icons here, in order to generate new outcomes. The blending we have been discussing is the mechanism that works a lot in a syntactic way with the representation that we have. Let me see if it blips. Yes. It didn't blip before. Then we produce the blend. We want to evaluate them, and then maybe we have a cycle here before we have the final, let's say, creative outcome. Now, how we represent this idea of direction of where you're going without having specific goals as in AI, because they are too specific. One way is using ideas, in fact, from computational argumentation, which is the idea of audience and values. I mean, arguments are not created also from nothing. They are created for a specific audience. Here I'm generating arguments because I'm in this particular conference. In another conference, I would explain the same things in a different way. The other thing is how you model the audiences. They use the idea of values, and values are linked to arguments. So certain arguments promote certain values, and certain audiences prefer certain values to other values. This is future research work, but the idea of direction would be that if you're writing a plot, maybe you are working on stories on some genre. This genre has an audience, and this audience has a set of particular values that you would expect they would prefer. So this is the general idea, that the evaluation can be open-ended, it can be social, and it can be linked to particular audiences and particular values that are what this audience prefers. So the approach in this paper is this idea of creating new computer icons by blending existing icons. Using this model of blending based on amalgams, we already saw that. And later we will show an example of how we can have a process of argumentation between a proponent and an opponent on the results of the generated icon. And then, as I told you, the idea is evaluation is an open-ended, reflective, and social process. Social process in the sense that some arguments may be generated by others, reflective in the sense that maybe the system in itself should be able to generate justifications or discover some properties that it doesn't like in the output. So the first is, what the hell is the rich background? Well, I don't know in general, but it's the representation you use, the knowledge you have, the examples you have. In this case, you have this bunch of icons. You see there the image, and then in here, there's in the small letters, the intended meaning, more or less. So in here, you're merging cells, you're merging columns. So you have the image and the intended meaning. This is quite clear, okay? So one way to deal with that is to view computer icons as a semiotic system. A semiotic system is basically a system of signs that conveys some meaning. Which signs do we have here? Well, one of them we will be using is the magnifying glass. However, the interpretation this sign is given in different icons that we analyzed is very different from one another. Sometimes it's examining something, analyzing something, previewing something, searching, finding. So it's used in different ways. We have a lot of polysemy here. Then we have the same here. We have this form of document. Sometimes it's called a document or a text or a page or a file. It can have different shapes, but if we interpret them all as the same sign, which is the document, so we have also variety in here. And then we have other examples like the hard disk and the pen that sometimes means you're modifying or editing or writing. Okay? So these are the signs that you see in icons all the time. You have the plus, you have the other cross that means killing a process or eliminating something. So every sign has a number of associated meanings that could be used to understand the intended meaning of the icon. In addition to that, these signs are related in the space, have relations in the space with one another. What we are using here are qualitative spatial relations developed by Zoe Falomir, now at the University of Bremen. They work on qualitative spatial reasoning, so they analyze images and they want to express relations that, like, you have this object or this shape at the left of the other one. They may be touching or they may be not touching. They may be up from one to another. And this is an example of how the relation in space with the same sign, which is the down arrow, is different from here to here, because this has a movement. So in here we would understand that from the sign that we have above, some sign, that it's up, has a relation up with the down arrow. This is the pattern saying you are downloading from here. And here you're downloading maybe a document or or text, and here you're downloading maybe music, maybe audio files. On the other hand, if the same sign is in the up relation with with another shape, like this one, it's downloading too, right? So in here we understand we are downloading to a hard disk or to an optical disk. So we have a set of relations like this. And with this we can describe the icons, which is, and then also these patterns that we can detect that happen not in just one icon, but in several icons. Okay? This is the idea of the semiotic representation, which answers a little bit your question before, where things come from. Of course, if we take it in the abstract without the context, we don't know. In a particular domain, we have a particular view of that domain, like a set of a semiotic system, then we have something like that. If you are familiar with construction grammars, maybe, they they are based on construction. A construction is a pair in which you have form and meaning. In the language, the form is the syntactical analysis of a sentence in a natural language. And then you have some representation of that meaning, maybe in unification grammars or feature structures or whatever you prefer. Interesting thing is that it's it's bidirectional. So if you have the form and go to the meaning, you are understanding. If you have the meaning, you want to create the form, you are creating or generating. In this particular case, we don't have natural language here, but we have this semiotic system to represent icons with the signs of the qualitative spatial relations. And here the icon interpretation is very simple. We're using just the keywords that we see in the icons that we have analyzed. So this is two examples of an icon. This is the real icon with a name. This is the representation we would have as a semiotic in the semiotic system. We have a pen above a document, and each one of them is associated a specific interpretation or meaning. And this one is search a hard disk. You have a magnifying glass that is above the hard disk. And here the associated meaning is search, and here it's hard disk. So it's quite straightforward. Just you have a variety of intended meanings. So we already see the blending and the amalgam. So one example of how to blend two icons. We have here the magnifying glass above the hard disk. The interpretation is that you are searching the content of that hard disk. In here you have a pen above a document, and the interpretation is you are editing, or it's an editor of a document. Now we can generalize. Basically, this is very simple. We can generalize two ways. We can keep the magnifying glass, or we can keep the hard disk. In this case, we have a magnifying glass that is above something that is just a variable. On the other side, we keep the document and not the pen. And then we have above something is above a document. And then we can, since these two can be unified, and we will get a new icon in which we have a magnifying glass above a document. And we would give the intended meaning as preview page. Why? Because one of the intended or possible meanings of the magnifying glass is preview, and one of the possible meanings of document is page. Now, this can be accepted or can be debated, that this is a good intended meaning, or that the icon really helps you to understand the intended meaning with respect to other similar icons, or not. So what we looked at here was some argumentation model proposed by Lakatos that was a model of dialogue between a proponent and an opponent that, according to him, is a rational reconstruction of how mathematicians work when they discuss with one another about mathematical conjectures. But it's mainly applied to mathematics. So we have an open-ended discussion. There is no, in other computational argumentation approaches is much more goal-oriented, and here is more open. That's why we choose to explore this. And the idea was to use what is called the Lakatos moves to structure a dialogue in which we evaluate possible icons that create. The possible moves, the first one is surrender, in which you accept the argument of the opponent and just say, okay, the conjecture or what I'm proposing was wrong. Then monster barring adjusting is a way of, the others work basically with examples and counterexamples. Monster barring is a way of excluding unwanted counterexamples. It starts with the argument that a counterexample given by the other can be ignored because it is not a counterexample, as it is not within the claimed concept definition. So this is not something I had in mind. Piecemeal exclusion is an exception barring method that deals with exceptions but excluding a whole class of counterexamples. So you accept that this is a counterexample, and all the class of counterexamples like that are excluded. And finally, strategic withdrawal is an exception barring method that uses positive examples of a conjecture and generalizes the conjecture so that these new examples are also in the scope of the conjecture. And this is a very simple scheme of the dialogue. The proponent presents a conjecture. The opponent presents a counterexample. If you cannot apply any of these movements, you have to surrender. And then this is discarded, and then maybe you go for the next possible icon that you can generate. And the other is that the opponent finally has not presented any counterexample, and then the dialogue is finished with acceptance. So the idea in here is that we will discuss about the intended meaning of the new blended icon, and basically let's say the values of what you're trying to not maximize, but what you're trying to deal with is all these possible ambiguities and polysemy of the signs put together in different icons. This is one example of a discussion. It's a discussion about page preview, which is the one we generated, and another one, which is called finding page. By the way, these two, we did not invent them. They exist. They are out there, and they are called like this. So in here, in page preview, you have magnifying glass. The idea is that you are examining without opening the document, and you can see some of the content. In here, the magnifying glass is above something like a document again, but it's interpreted as finding in this page, maybe because it's a browser or whatever, and the document is called a page. So the proponent says an icon with a magnifying glass over a page means a preview page. And then the opponent gives the one we have seen as a counterexample. I disagree. This icon for me means finding a page, finding page. And then the proponent can counter this attack, saying, no, this is a different case because the magnifying glass must be over pages with text on them to magnify. It shows that we are about to magnify. Like you see in here, you have this difference, so you're going to the more detail. So this, I think, is related to the discussions we had in this conference about the system being capable of justifying why it's choosing some particular output. So this is not implemented yet, but in the long run, what we would like to have is a system that is capable of generating these counterattacks to the attacks of the opponent based on the knowledge that he has, maybe also comparing this new icon with other existing icons, of the polysemy of them. This is another example. The two first moves are the same. So this agrees. For the opponent, it means finding page. And this is another way to counteract with a different move that says, okay, only icons with a magnifying glass over a page with text mean preview page. So you see it's not exactly the same as before. So the idea is that this kind of argumentation based on dialogue has several advantages, promotes open discussion around the meaning of the icon, but it can also construct a discourse about the intended meaning of an icon or the intended properties that you want to have, so that you don't have the purpose or the specific criteria by which you judge something as being better from the beginning, but they emerge from this dialogue. Future work, well, as I said before, the idea of using value-based argumentation in which the purpose or the destination of some creative artifact depends on the audience it is intended for, and the audience is represented as with a set of values that are linked to the possible arguments that you have. Another different approach that we could pursue is whether this argumentation process is social, so it's between the system and other agents that can be computational agents or human agents, or can be what in computational argumentation is called practical reasoning, which is the agent reasoning in itself about the pros and cons of different options, or a specific option, like compared to, like here, an icon compared to existing icons. And then finally, this idea of including in the computational model some way to generate arguments or counter-arguments to the attacks of the arguments of other systems. And that's it. Thank you.
Any questions? Kaz, pink shirt.
That's never dying. So, in the case where you're having one of these structured arguments between different agents, have you thought about what you might do if those different agents, because of their different past experiences, both hold equally valid for their subset of things that they've seen, but competing views?
But you don't know the views. You just know what is expressed as an argument. So, to rephrase your question, what the agent can do is, in computational argumentation in general, not just in the Lakatos approach here. Usually, you propose something, the other attacks, and the only way you have or one of the ways you have to defend yourself is to attack the attacking argument. However, there is no central decision maker that says when something wins, which attack, if the attack to the first one prevails or the attack against the attack prevails. We did some work in multi-agent systems that they talk to one another about what they have learned, and they discuss with one another, and each of the agents are the ones responsible for deciding if they accept that the argument attack wins, and then you say, okay, I concede, or not.
So if the two agents have mutually conflicting sets of beliefs,
yes,
then they will just continue arguing ad nauseum, as none of them will ever surrender to a valid counter-argument.
If they have an infinite number of arguments, but you
they
cannot
can
repeat.
stop without winning, without either winning.
It goes without saying that you are not allowed to repeat your argument, so it's not like in politics.
Ashok.
So if I can go back to the notion of goals for just a second, it seems to me, Henry, what you and Amilcar are saying could be very powerful. So one of the major moves that occurred from pre-1990 AI to post-1990 AI was a notion of goal got expanded into the notion of utility. I think one interpretation of what you and Amilcar are saying is that in computational creativity, the notion of goals is getting expanded into the notion of values. If that is correct, if my interpretation of what you and Amilcar are saying is correct, that's a very powerful idea. But is my interpretation, would you agree?
Yeah, I mean, the idea is that you have a destination which is, let's say, an audience. So if you want to write a mystery novel, you know what kind of audience is there, and the plot has to keep you always intrigued, and you want to know what happens and things like that. So there are certain values that this audience holds. Now you can critique some output, saying, for instance, that the rhythm of the novel goes very well until in the first half, but in the second half it loses focus, or it loses interest in all this mystery, just dissolves, and whatever. The characters do not act like that. So the idea would be that it's the intended audience that gives you some constraints on what is good or better quality. But this is not fixed. It has to be discussed. It has to be argued, and in some way, it's never finished. I mean, I love the Matrix movie. People hate the Matrix movie. We can talk about the Matrix movie now and 10 years ago, and probably in the next 10 years.
Okay, one last question.
Yeah, I had a question actually going back to your first talk where you referenced Gogin's algebraic semiotics work formalizing conceptual blending, and then said that it has a problem because it's based in category theory, and then this is where I didn't quite follow what was the problem with it being based in category theory. And I know
we are working also.
Yeah,
the formal model,
category theory.
We are working with
it.
it also category theory.
So what was the problem with Gogin's account?
The problem with Gogin's account was that he could not use a simple form of category theory because of the partiality of the morphisms. And usually in category theory you have these different diagrams, and you check that they commute.
Right.
But then they had to work with a special kind of morphism, which was a partial morphism, and then an order between those morphisms and so on. And this was a very complicated, technically very complicated model. It's called 3.5 category theory.
So are you suggesting that from a system building perspective that building a system based on that would be harder than building a system based on your account? Because I know
what we are just saying is that you can model, he modeled partiality, so the projection from the input to the blend, it's partial. You're not projecting.
Right.
You're projecting part.
Right.
Now the thing is how you represent this partiality in category theory. He chose to do it one way. We
Okay.
chose to do it another way. However, the combinatorial complexity does not disappear because we have the inputs, we have generalizations, you can have a lot of them.
Okay.
So for each pair of generalizations, you have to see if they are consistent, then you have a blend, you can have a lot of blends. If they are inconsistent, then you go to the next, but the combinatorial problem is still there. So the answer to the previous question that you made, I think that how you could constrain this is, instead of thinking in general about trees and signposts or whatever, because you are dealing with some particular task, like writing novels or designing icons, and then you have some domain-dependent knowledge that allows you to decide things or prefer things to other things.
Okay, let's thank all the speakers of the session. And now we hand you over to the one, Neo Ventura, who's going to tell us about our